sometimes information from a geometric series will be missing. That will make the sum formula not possible to use at the beginning. So instead, use the formula for the terms in a geometric sequence to find out that missing information. Then you can find the sum once you have that. So plug in the given information into the formula used for a geometric sequence, solve for the missing information, whether it's the first term or the rate at which the sequence is changing, and then plug that information into the sum formula and evaluate. That's how you'll find out the value of a geometric series. Let's try an example. Find the sum of the first 5 terms when the first term is 16, the fifth term is 81. So we have to find the sum of the geometric series when these conditions are met. Take a moment to pause the video and try to work out the solution by yourself, and when you're done, unpause it. So find the sum of the first 5 terms in this geometric series if the first term is 16 and the fifth term is 81. Well, we know what A1 and AN are, but we don't have the rate. So let's substitute those values in to our geometric sequence formula. So we have 81, or AN, which in our case n is 5, is equal to 16 times r raised to the 5 minus 1 power. And then we can simplify this by dividing both sides by 16 and also subtracting our exponents. So we have that 81 over 16 is equal to the rate raised to the 4th power. And then if we take the 4th root of both sides, because it's an even root, our value can be positive or negative. So it's going to be plus or minus the 4th root of 81 over 16, and the 4th root of 81 is 3, and the 4th root of 16 is 2. So we have plus or minus 3/2. Now we can substitute all the values that we have into our geometric series formula to find the sum. So the sum of our 5 terms is equal to our first term, 16, times 1 minus 3/2 raised to the 5th. This is the positive option, and then over 1 minus 3/2. We also have to consider the negative option. So we have 16 times the quantity 1 minus negative 3/2 raised to the 5th power over 1 minus negative 3/2. Now let's evaluate these expressions. We need to start with our exponents. So if we do 3/2 to the 5th power, we end up getting 7.59375. And if we evaluate negative 3/2 to the 5th power, we get the negative of that, so negative 7.59375. And then when we do the subtraction in the denominator, we get negative 1/2 or 2.5. Then if we evaluate this again, finish what's in the parentheses, we get negative 6.59375 and 8.59375. And then when we multiply and divide, we find out that our sum could either be 211 or 55. It depends on if the 3/2 is positive or negative.